presentación en inglés. Ya tiene un poco de español, así que las preguntas las podemos hacer en español si queremos. O en inglés, como quieras, ¿sí? Caroline, you're welcome. Thank you for accepting the invitation.
Well, thank you for this very nice introduction. I will be at the end of the talk very happy to take questions in Spanish. It's okay, but I think for the presentation, it's easier if I give it in English. So thank you for being here. I'm very happy to present you my project called Genesis of the Rosablanca emerald deposits and comparison with other emerald deposits in Colombia. To make it short, I would like to take you to the field with me to show you some impressions, some pictures, and some ongoing work related to the hydrothermal fluids, to the timing of mineralization, and some gemological characterization of this emerald. So emerald has been known and appreciated for centuries in many cultures. We have first record in ancient Egypt as well as here in Colombia from indigenous people. They were used for many different purposes, such as for ceremonial purposes, amulet, ornament, symbol of status, and diplomatic gifts. We have here an example. This is from the Gold Museum here in Colombia. This was tiny gold human person with an emerald in the middle from the Musica indigenous people. And today, emeralds are still one of the most precious stones. This is one example of an emerald, Colombian emerald, that was sold end of 24 for 7.7 million Swiss francs. This is more or less $9 million US. So it was huge records. And another example, this is in 21, a famous actress that has a very nice emerald necklace, Colombian emerald. So emeralds are still very fashionable, very desirable, and wanted in the trade. Emerald is a mineral from the beryl family. It's a beryllium aluminium silica oxide. It has an hexagonal crystal structure. We found the aluminium in the octahedral coordination, and the silicate and the beryllium in the tetrahedral coordination. Pure beryl is colorless, and the color of the emeralds come from trace elements of chromium, vanadium, and more or less iron. The content of iron will influence the vividness of the green. If you have a lot of iron into your emerald, the green will look a bit less vivid. And in Colombia, we have the particularity to have emeralds with a very low iron content. And this is one of the reasons why people say the Colombian emeralds are the most beautiful one on the earth, a very vivid green color. This is related to the iron contents present in the mineral. In the structure of beryl, we have channels. So we have the silicate ring, building channels. And into these channels, we can incorporate various elements such as water, two types of water, depending on the orientation of the water molecule, and cation, such as sodium or potassium cesium. We think that in order to bring a green color to the beryl, we need some trace elements, chromium and vanadium, to make the green color. And to bring these trace elements into the lattice of the beryl, we have different ways to substitute elements. We have simple or coupled substitution. Basically, we will replace aluminium and/or aluminium and beryllium with other cations. Emeralds are found in Colombia, but also in other places of the world. But today we will get focused on the Colombian emeralds. And to be more precise, we will go to the Eastern Cordillera in the region of Boyacá, where we have all the emerald deposits. All the deposits are hydrothermal. which is very unique for gem quality emeralds. They are all formed in low Cretaceous sediments, and we have a division between the western belts and the eastern belts. Just to give a very brief bullet point of the large-scale geology, so we had from Triassic up to early Cretaceous rifting phase with an extension phase, followed by a back arc phase, which compressed the entire system until the late Cretaceous. Uplift of the central Cordillera. We have two different timing for the mineralization of the emeralds. First, on the eastern belt, here 65 million years ago, and then a second event here for the western belt around 35 million years. Then during the Miocene, we had the uplift of the eastern Cordillera, and today this is a sketch of how does the local geology look like. So quite complex, a lot of fault, a lot of tectonic activity. For the rest of this talk, we will stay to the western Cordillera, which is my study area, where we have the two stars. One is related to the Muso region in red, and the other one, Peñas Blancas, in orange. In the western belt, we found two geological formations where we have emeralds. The first one is the Muso formation, and the second one is the Rosablanca formation. You have here a map showing you in brownish here the Rosablanca formation. In blue, this is emerald mines. And in pale green here with the red dots, these are emerald mines from the Muso formation. We have several studies that have been published on the Muso deposits. We have a general understanding of what happened in that region. We know that the Muso formation is up to 300 meters thick, and we found emerald in calcite-rich veins into black shale. So the black shale is the host rock. It's a soft, graphite-rich mudstone. We have a low-grade metamorphic condition around 1 kilobar and 300 to 350 degrees. For the Rosablanca deposits, we have actually little to no data that has been published. We know that this formation is quite thick, up to 1 kilometer, and we found emeralds in limestone. With this, I'm coming to the aim of my work. We try to reconstruct the genesis of emerald deposits in the Rosablanca formation. So that means we want to understand the mineralization processes, to constrain the timing of mineralization, to identify genetic similarities and differences between Rosablanca and Muso, and to make a gemological characterization of these emeralds to see do we have any differences between the Rosablanca deposit and other Columbian deposits, and generally from other global occurrences. Why do we want to do that? Well, there's a genetic model which is partly based on descriptive evidence, and we have scarce geochemical investigations. We have a poor timing constraint and often contradictory. And in this region, all genetic and exploration models are based for Muso deposit only. So this work is done with mining companies in the region, and for them a deeper understanding of the emerald genesis will lead to a better and more efficient prospection and exploration of the emerald deposits in the region. With this, we have several approaches to reach this aim. The first one is to look at the element and the fluid sources and hydrothermal fluid transport. That means the geochemistry, fluid inclusion. Then we want to understand the emerald's precipitation mechanism, which are what are the main mechanisms that lead to the mineralization of emeralds, dating of hydrothermal mineral, when this thing happens, and an emerald characterization. to establish a source locality tracer. We will use several methods. I mean, the first one is literature research. We are not starting from scratch. Work has been done. The second one is field work. Go there, make observation, take sampling. Once we have the sample, petrochemistry of the host lithology. It's going to be very important. Thin section to understand what do we have for host rock, host material. Precipitation sequences of hydrothermal mineral and alteration stages within the host rock. And a detailed fluid inclusion research in order to better understand what do we have for hydrothermal fluids. And we plan to do that on quartz, emerald, fluorite, carbonate, maybe other material depending what we have. And the last, regarding the emerald's geochemistry and physical properties, this is a mix of traditional gemological work, observation with the microscope, and then ICP-MS and FTIR in order to have more precise data. With this, I would like to show you how is the field, what we did, where we have been, and I will start with a map. This is again the Rosablanca formation in brown, and in green the Muso formation. The blue dots represent all the visited sites between 2023 and 2026. So I have been 3 times in the mines. For 23 was a very short time. It was more a kind of introduction and meeting people. And 2026, we spent 2 weeks in the fields, and I came back last week. So we have been in the Rosablanca formation in 2 sites, one called Oñez Blanca and the other one Monte Blanco. We visited 5 tunnels and a few road outcrops. And in the Muso formation, we have been mostly to Muso and Cosquez, and we visited tunnels. This is the profile from this part here, going through a tiny part of the Muso formation and the Rosablanca formation. So for the Muso area, we have been mostly to Muso mines and Cosquez. We found the emerald deposits in calcareous and non-calcareous mudstone, which is called black shale. You have here on the side stratigraphy with the main lithologies. We found the emeralds into this mudstone. The emerald are found in hydraulic breccia and/or vein made of calcite, dolomites, albites, quartz, and pyrite. It's a very hill landscape. We have a lot of vegetation. Basically, it's an amazing landscape, really, really nice. But it makes it sometimes a bit tricky to find good outcrops because you have vegetation everywhere. And if you have a good outcrop, 3 months later, you have a tree. So tunnels are a bit better for that. So regarding the local geology, we found the emeralds in the mudstone called black shale. It's very soft, a dark color, rich in graphite. We have 2 different kinds of mudstone, one which is calcareous and one not. The only way to test it in the field is with acid because visually we don't see any differences. This is a close-up of this black shale, again, very dark. In order to find the emeralds, well, there's different criteria. We've asked in the mines how do they proceed, which kind of mineral or criteria they use. And this is a list of the point of interest that they have and how they are looking for the emerald. So they look for certain minerals which are associated with the emerald, like pyrite, which is a rare earth element carbonate, and fluorite, vein containing abundant pyrites, vein containing abundant albites, vein which are close to heavily altered black shale, called salicero, meaning ash trail in English, veins intersections, and folded breccious sediments. So this was the main things that were currently good in order to target the emerald. And in the fields, we went through these points and see, can we find this? Does it make sense? Regarding vein containing abundant pyrites, definitely. We found huge pyrites. We have here a very nice example with an emerald. We have here the vein with a lot of calcite. We have pyrites here, and this is the host rock. We were not really able to see abundant albites. We found few samples where potentially it is albites, but quite tricky to recognize and to find. And here another example, also with the emeralds here in a carbonate vein. Vein containing fluorides, pyrrhizides, plus minus fuchsite. So these are minerals that are less abundant, but however, usually associated with emeralds. So here I have one extraordinary sample with pink fluorides. We've seen it only a few times, calcites, and here we have the pyrrhizides. And here another example, we have here the emeralds, here was fluorides, and here pyrrhizides. Vein containing quartz. Well, we have seen quartz in the fields. Here, again, the example of a quartz crystal close to a pyrite, very large quartz. These large quartz were usually not directly associated with the emeralds, but described as being close to the emeralds. And we found a super interesting samples with a quartz containing emerald inclusion into it. This is the first time that I've seen something like that. Quartz inclusion into emeralds. We have seen it, but the opposite way. This is the first time that I observed something like this. Regarding the brackial sediment, well, definitely, we've seen a lot here, very nice example in green in the emerald. And we had two different kinds of braccia, one with silicified rock fragments, like here. And regarding the Seminario, this alterated black shell, here an example where it looks very gray, same consistent, just very gray. And here another braccia. So if we summarize everything, and we took also what we could find in the literature, what we know at the moment regarding the Muso emerald deposit is that emerald form due to a mixing of two different fluids. So we have here the black shell, this mudstone, which contain all the goods, all the chemistry we need to form the emeralds. And we have two different fluids coming from evaporitic layers below the Muso formation. The first fluid, which is dominated by natrium chlorine, and this one will form fluorine beryllium complexes and transport the beryllium. And a second fluid dominated by calcium, potassium, iron, and fluorine. And this one, when bleaching the black shell, potentially form this cenicero and get enriched mostly in metal, like the chromium and the vanadium we need to give the emeralds its color. When these two fluids meet, at some point, we have a pH that increases. We have first an albitization phase, followed by a carbonatization phase. And precipitation, then second stage precipitation of fluorides, pyrrhizides, and carbonates. This will destabilize the beryllium fluoride complex, but which leads to a final stage of emerald mineralization. Everything is made at low grade temperature metamorphic condition, more or less 1 kilobar and 300 to 300 degrees. Regarding Rosablanca formation, well, we are here in this brown part, and this formation is much thicker. It is divided in three parts. We have an upper and lower part made of thick limestone, quite hard, and the middle part is described as being more soft. Here again, the stratigraphy of the Rosablanca formation and the emerald are described to be somewhere close to the upper part, so somewhere close to here. Again, landscape is very hilly, a lot of vegetation, and this is an example at the exit of the tunnel. They bring all the material and then look again for the emerald, and this is how we got most of our samples. This is how we got the tiny emerald that we will use for the emerald characterization, but also rock samples because we have a better light and we can better see the material. In the mine, sometimes it's very dark and everything is a bit more dusty. So the material that was brought from the mine just in front of the mine was actually a very good place in order to find good samples. If we go through the stratigraphy, the upper part is described as being limestone and containing fossils. So in the field, we were able to find 2 fossils, not that much, but could be a good indication to be close to the upper part or in the upper part. A lot of limestone. Everything is made of a thick block of limestone. When we go a bit deeper, we have still the limestone, and at some point we have mudstone that come. Here we have a transition zone example. We see that the texture is a bit different, and this is the best way to make the difference between these 2 units, because based on the color, they look exactly the same again, but the texture is changing. The limestone is always very thick, blocky, while the mudstone it's fine grain and usually, or in some cases, folded. Here, other example of the mudstone that we've seen in the Rosablanca formation, right, folded. And example of the emerald mines, emerald veins. So a lot of calcites. Here we have the emeralds, and the typical assemblages that we observe is with the limestone. Here, the host rock, we have an iron-rich carbonate, probably anchorites, calcites here, and the emeralds. And the emeralds form either into the veins here, or sometimes here at the border, reaching the limestone. Another example of the vein, so this one contains much more iron-rich carbonates, again the emerald here. And in this region, we also find the trapiche, which is a very particular way to form the emeralds and have this extremely characteristic look. So we have a different generation of veins that we were able to observe in the field with some cross-cutting relationship. And what we observed is that the emerald veins are subvertical. They have an orientation more or less 80-90, and they are mostly perpendicular to the limestone bedding. We've been to several mines, and this is something that it was constantly the case. We took some measurements, and we also asked always the miner if this is the case, how is the orientation of the vein, and it was systematically the case. The good veins or emerald vein are usually subvertical. We found also large quartz, not directly with the emerald, but close to it. So quartz is also associated here with the emerald. If we go a bit further down into the stratigraphy, so this part here is described as having claystone layers, still a lot of limestone, might contain pyrites, larger pyrites, and we still have the mudstone layer. And this is things that we could observe in the field. So this is an example with the claystone and mudstone. We still have this very thick block of limestone. we observed in one of the concessions called Monte Blanco something that were actually very similar to the Muso formation. We had this kind of black shales or folded here outside. We had some very alterated pieces, really looking like a scenic level. And this is example of what we had. So we found some breccia, partly silicite. We had pyrites, bits larger. We found tiny black quartz, probably chalcopyrites, based on the color. And we also had some cavities. They said that some of the emeralds might form in such cavities. Here an example without emeralds, but since we have this cavity, the potential to form the emeralds in this kind of setting is there. And on the very bottom part of this formation, I presume we were on the bottom part, we found a lot of mudstone and a lot of fuchsites. Actually, it was one of the mines. They were hoping to find emeralds there, and they found only fuchsite, so they stopped to work the mine. But it was very interesting and very impressive. We also had some dolomite, which was not really observed too much in the other tunnels. And here again, in the background, so this very dark rock material. So I tried to summarize a bit everything we saw in the field with a very simple sketch. We had from the top, so elevation base in the mine that were located very high. We had a lot of limestone. The productive vein were subvertical. The unproductive vein were usually other orientation, or less horizontal. This was the region called Peñas Blancas. We have seen some breccia, but not as clear as in the Muso area. We have in the bottom part a concession called Monte Blanco, which in this case were very similar to the Muso one. We had still a bit of limestone, but a lot of shale. So this limestone, we had breccia, we had vein in different orientation. And they told us that they called it the Muso shale. And one of the hypotheses they had was we had an inversion of the formation, and because normally the Muso formation is located on the top from the Rosablanca formation, and they thought that with the kind of inversion we had here on this bottom part, Muso formation. Question mark. Maybe, maybe not, but from observation, it definitely looked very different in this part here. So to summarize a bit the two formations, what we know, well, we have emerald in both formations, which is very interesting. Found for the Muso one in the vein, hydraulic breccia, in Rosablanca vein as well, very common, sometimes directly into the limestone. Regarding the vein composition, they are quite similar with small differences. Albite, for example, is something that we could find only in Muso, which is also from the literature only described in Muso. Pyrites is a very important association, while in Rosablanca, it's not really described. In the field, we found some really tiny ones, but not as big and impressive than in Muso. Regarding the emerald composition, well, at the moment, they look very similar. I don't have so many data at the moment. It's a work in progress, but from what we have been observed, looks very similar. Fluid composition from the literatures, we have good data regarding Muso, and we are expecting to find similar data for the Rosablanca formation. Same for the metamorphic condition. We are not expecting to have something completely different for the Rosablanca. So probably, well, we will stay to a low metamorphic condition, maybe a bit hotter, a bit cooler, maybe, but not big differences. We have already some ongoing work regarding the hydrothermal fluids. We decided to check the fluid inclusion into the emerald, the fluorite, and the quartz, because these minerals may be associated together. In all these minerals, we found 3 phases inclusions. With the Raman, what we have is, well, a gas bubble, which is mostly CO2. We had a squared solid, a very nice shape, and combined with no Raman signal, it's actually a very good indication for halides, because halides do not produce any Raman signal. And regarding the fluids, what we have is at a higher Raman shift range, some water banks. So we have a kind of aqueous liquids. This is what we got from the Raman. We will do then further analysis in order to have a better characterization. But the Raman spectra of these 3 inclusion into the quartz, into the fluoride, and into the emeralds were similar. What we have done as well is a thick section with the emeralds, and with the FTIR, you can actually see water donation. And this is something that we try to see do we have, how is the water dispersed into the into the samples? Do we have any zonation which are higher, lower? Do we have anything interesting? And we did actually. So here we have the water contents that is shown in blue. It's a low water content. In red is a higher one. We have here the typical average spectra for a low water zone and a higher water zone. And we also see a negative correlation between the water and the CO2. And what we also observed in that sample was kind of a correlation with the green, like a darker green zone. Here, for example, here there's also a bit a darker green zone, more or less correlated with this part here. So this gives us actually very interesting information. It's going to be very good to combine this technique with other instruments in order to have a better characterization of our samples. We've seen at the beginning that into the beryl structures, we can incorporate water, 2 types of water, depending on the water molecule. And this is something that we can actually detect with the FTIR, because the peak are slightly shifting. And that's also something we are now trying to see, to map the emerald in order to better characterize the type of water we have, and associated with the type of water, which kind of cation we have. Do we have also the presence of CO2, which is a peak that we can detect with the FTIR and other cation. So again, this combined with other technique is going to make a very nice characterization of our hydrothermal fluids and generally of the composition of the emerald, repartition of elements, where is which element exactly going. We have another ongoing work regarding the timing of the minerals. One good candidate was pyrrhizite. This is a rare earth element carbonate, and this one was associated with emerald together. Generally, regarding timing in the literatures, we have very different ages. So we have a literature agreement that says 35 million years, but we have several studies that has been done showing ages going from more or less 97 to 12 million years. One study did this pyrrhizite age dating with thorium and blood, and got an age on more or less 50 million years, and we were trying to reproduce the same. So we have pyrrhizite. We found it in one of the few samples that are already in Switzerland. We know that we have a lot of pyrrhizite in Muso. Rosablanca less. Actually, on the top of the Rosablanca part, they said no pyrrhizite. This one was coming from the bottom part. And what we plan to do was first to check do we have any introduced parasites, do we have any chemical zonation. We are now looking for proper standard for calibration. Once we have that, we can collect the data, and we plan to double check the age with TIPS and other methods in order to see do we have with the same samples two methods the same age. So what we have at the moment is we had a quick view with the STM. So we have donations that are visible, but they are not too strong. So the parasites doesn't come to be too chemically zoned. We plan to use monocyte standards, maybe another one. I mean, if one of you has suggested, we are very open to try a new thing. In the study that Altenberger et al. Did, they performed all their works in a lab in China using a bactericide standards. But this lab is not sharing actually any information, not standard and not many information. We just know the standard they used, and we will try with another one to see if we have a comparable age. Coming to the gemological characterization of this emerald, well, this is a quick overview. It's a very gemological work, looking at inclusion with the microscope, which kind of inclusion is typical into the emerald, what can we find. This is the list of the most common things we could observe. And quickly, between the Muso and the Rosablanca formation, at the moment, we see very similar things. So we think that we have, from a gemological perspective, same data. Regarding the UVB spectroscopy, exactly the same. The variation we can have between one spectra on the other is rather related to the green saturation of the samples. So a very pale green or dark green will provide slightly different peak, but basically looking at this spectra, you cannot make a distinction between these two formations. And last, minor trace elements present into these samples. Well, we had only 8 samples from Rosablanca, so this is semi-representative, but at the moment we don't see any cluster. So we think that these emeralds are basically the same. To conclude, well, field observation reveal new links in the emerald paragenesis, including quartz forming after the emeralds. This is something that we have never really observed or seen in the literature. The sample collected in the fields, particularly the quartz, will provide valuable data on the characteristic and evolution of the hydrothermal fluids in the system. Then the bulk composition will provide essential insights into the chemical sources and geochemical environments responsible for the emerald formation. If we can date parasites, I'm very optimistic, but I think it will work. We will have good data because we have samples from different locations within the Muso formation, and I think they should all give an age which will be quite homogeneous. Gemologically speaking, Muso and Rosablanca formation produce the same emerald. So because we have this same emerald composition formation, we are expecting to find as well the same geological processes in order to form the emeralds. And with this, I'm finished. Thank you for your attention.
Bueno, muchas gracias. ¿Preguntas?
What is the closing temperature of parasites?
The closing temperature of parasites.
Of your data is?
Well, since the entire system is at a very low metamorphic condition, I assume it will be close to that, but I don't know the exact number of the closing temperature of parasites.
Because I mean, looking at those ages that have been obtained, you can question those ages, say that they are representing those tectonic phases associated to the economic eastern culture instead of the age of the minerals.
I think on the minerals that they choose to date, some of them definitely formed before or after the emeralds. This is also one of the tricky parts. I mean, we can date mica easily, we can date apatite, today is not a problem, but you need to find the sample that form at the same age of the emeralds. And because mica and apatite can form before up to the mineralization of emeralds, we choose to focus rather on this mineral that is described to be formed at the same time of emeralds. We have, however, one sample where we see the emeralds and we have some fuchsite, the green mica, just next to it. So that's potentially something we try to do. I mean, it's going to be only on one sample, but if we can date that mica and see where do we stay within the timing, the age, might be interesting. So I think regarding the timing, the most challenging part is to find the right mineral that will give you a date which makes sense.
I also have another question. It's one of your last slides. Would you show the concentrations of vanadium, for example, on BD and thinking? Now, so you have concentrations of vanadium in the order of percentage, right? 80%.
In part per million.
And that's going to be 8% also, right? It's equal to 8%. 3,000.
Yeah, so yes.
So how can you get such a large concentrations in a rock? What is the processes that concentrate those minerals that are real sensitive? They are not very well done in the outer. So how do you get those enrichments?
So these are the concentration of the emeralds. And I don't have any chemical data on the host rock. I don't have them yet because the samples from the last field work never arrived in Switzerland. So the supposition of what is at the moment described and understood in the literatures is that you have all the right chemical elements present into the black shale, and that these fluids will get enriched in certain elements, and then because you have several minerals that precipitate before the emerald, parts of the chemical composition of the fluid will get removed. For example, the iron, you have a lot of pyrite that precipitate in the region, so it will remove the iron contents into the fluid. And I suppose at the end you had a fluid which is highly enriched in vanadium, chromium, and this is how you can have such high value into the emeralds.
Yes, it's not 80%. Under my chapter is 0.8. It's
0.08. No,
0.8. The sales is really high for a year. And those rocks should be higher, so it's really interesting to see that in terms of elemental composition of the rocks of the minerals.
I think that's going to be awesome to have the chemical data of the oil rock for the limestone and also for the shale to see how much of the chemical elements for the emeralds are present into this rock, and is that really the source, or do we have something else that we didn't understand? But at the moment, the general understanding states that everything we need to form the emeralds is into this black shale, and we will see if this is matching or not. Another point is chromium and vanadium are not that easy transportable. So it makes actually a lot of sense that we have this element present into the black shell, because this is the surrounding host rock. And as my understanding, vanadium and chromium will not come from 100 kilometers away, because they are not that easily transportable. So I hope it will make sense to have everything in the
This is
same.
probably a stupid question, but we can deal with pictures, the photographs.
Mhm.
Those things are huge. So how long does it take? I remember crystal to grow, fluoride crystal of that size to grow.
Oh, I think that can take 1,000 years, maybe million. I think you were speaking of.
No idea.
Have you seen anyone got this out?
Yeah.
Well, no, son those cycles that it's huge.
Because I mean, I'm thinking of the thermodynamics of these things and the equilibrium. Something that is driven by mechanics. And this is going to be driven by equilibrium. Such a huge crystals, it's going to be a process of that standard. I mean, I'm just thinking of the size of the crystals. Which they are huge.
Some of them definitely, but I cannot. To be honest, I don't know how long you need. I can imagine that it can take up to thousands and thousands of years, as long as you have a system which is stable. The crystal can grow, and as soon as something is changing, either from the grid composition or temperatures, or any changes will stop the growth. So my samples are not so impressive. Yeah. My samples are very tiny, so I think this one are quite easy to be grown. And the very large crystals are very scared. Yeah, this is why they are so famous. And when you see a crystal like this, that's crazy that you can find such a big crystal forming the deep.
I have a question.
Yes.
But before the question, I know chlorophyll garnets. There are 2 million years for like 1-2 centimeters. I guess those are more the reactions like are slower. I mean, very it could be a million years. Could be. My question is related to the pressure and temperature estimations how they were estimated.
With microthermometry.
You see.
It was on inclusion in emeralds.
Inclusions. Okay.
Yeah, fluid inclusion, sorry, in emeralds and in quartz.
Okay, so you don't have estimation, the host rock, you see.
No. Regarding the host rock, there's nothing. All the data that has been done in the past studies, it's going from the 90s up to a few studies.
Okay.
In the 2000, I think 2021 is the last one published where I saw some homogeneous temperatures. It's all done with microthermometry based on fluid inclusion.
Okay, but you have to take into account that chlorophyll has been found in some rocks.
You
That constrain somewhat the percent temperature too.
Yeah, you do
And
need
when
to
you have
find
the
some.
temperature is yeah.
No, definitely, I agree. I think in the best case, when you have different angle of attack and everything is turning well, then you have a strong story. So I will also do the fluid inclusion study, the microthermometry. We have now a good sample to do so. And regarding the host rock, I mean, I think we also have samples with a good potential to do other study regarding the timing. And I mean, why not? If we have good results.
I have one question related to that. the temperature and pressure estimations and the mineralization.
Mhm.
Do you think the emeralds form during exhumation? We're still thinking, worried about the sanitary fire.
Well, from what was published, it said that emerald formed before the exhumation.
Before?
Yes.
During the,
Well, was it emerald formed 35 million years ago, and the exhumation of the Eastern Caldera is 10 million years ago.
Yeah.
So they formed before. And from what we've seen in the fields, like the relation of the folding of the host rock, breccia, the veins, I haven't seen. I need to think. I think the host rock was already folded when the mineral formed, so that might happen actually during, for example, the uplift of the central caldera. I can imagine that you had also some tectonic events that were pushed into the background and folded part of this black shale, which are very soft. And then into this fracture, we see sometimes a vein, an emerald veins cutting this fracture. So, or cutting, sorry, this folded black shale. So, from observation, we have stages that we can say based on observation. We had first, this black shale that were folded. Then we had a stage where we had breccias, we had veins containing emeralds. And when everything was uplifted, I still have personally a lot of question mark how everything exactly happens.
you also remember that in the Eastern Cordillera, we have several peaks of intermolecularity.
Mm-hmm.
Even so, they are very old ones, but the ones related to exhumation, for example, the elements, they always could be around 45 million years. There are all peaks of 25, 85 million years. So I think those could be related to the formation. I don't know.
Like they are also different when you compare the western part of the eastern Cordillera and the eastern part of the eastern Cordillera. There are different.
Some both sides.
Yeah.
Yeah, that's a good point.
Carol, thank you. Congratulations for being nice. I believe that the logistic approach that you have used will be in the future. I'm looking forward to learn more about Colombian minerals. But we have a very simple. At the conclusion, you said that the geological model for minerals was occupied in Chile. And you know very well that the quality of the blancas minerals also are totally different.
Yeah, that's that's a good point. What they explained me is that in Rosablanca, the emeralds have a lighter green. You don't have this very strong, what they call it, muso green, this deep vivid green. So based on the coloration, yeah, apparently we do have differences. And this is something that we can also see within the muso formation. We do have different shade of green. We have emeralds with a very strong vivid green, some with a paler green, and at the end, this is related to the concentration of vanadium and chromium that you can build into the emeralds. What we are expecting for the formation in Rosablanca is still expecting the same mechanism, but probably the fluid is less enriched in elements like chromium and vanadium, and that's my play on the color. But if we check other elements, And here I put only two examples. But if we check other elements, we are still in a very similar ratio. We don't see two distinct clusters. We see rather cluster when we select the samples based on the color only. So one of the hypotheses is that although we have the same mechanism, the composition of the fluids might be slightly different. And this is what would give a slightly different shades of green to Peñas Blancas emeralds or Muso emeralds.
I have a question regarding data. So you are like have many challenges with the standard for calcite, but why did you don't constrain with the calcite? It should be different if you take the calcite or if you take the calcite.
With the calcite, I need to find the right calcite samples. That was more the challenge on this part because we have a lot of calcite in the vein. I mean, we could state that. I'm not sure how much sense it would make. Probably the calcite in the vein is prior to the emeralds. So we could have an age where we know, okay, emeralds must have formed after. But regarding calcite, I think the biggest challenge would be to find the right samples to be sure that we are not dating something that is just, I don't know, it formed way before and we have an age that is not really helping us. With the samples we collected, I mean, if we find, for example, a good calcite inclusion or an emerald in a calcite that grows gently, that could be a good candidate. I'm less aware how to use, which method to use, but I know that I think in Bern or Geneva, they are doing the datation of calcite. So that could be, if we have a good sample, that could be an option. Yes.
Do you speak Spanish?
Sí, one point.
Yo trabajo en las esmeraldas desde el 2006
Sí.
y conozco el cinturón oriental como el occidental. Sí. ¿Por qué tú decides use the geological map of service geological Colombia? Si por lo general los geólogos franceses, Frankel, chilenos, utilizan los mapas antiguos, o sea, la formación baja. Lo mismo pasa para el oriental, para el cinturón oriental. El oriental se unieron unas formaciones como Guará, Chivor, Santa Rosa, pero nosotros los geólogos que hemos estado en campo sabemos que esas formaciones no son, digamos, por así decirlo, de fácil manejo. Son mejores las que teníamos antes, que eran el Guau y Macanal, las cabezas del Guau y Macanal. Entonces, ¿tú por qué decides trabajar con esta nueva estratigrafía de Rosablanca, Muso, Capotes? ¿Por qué si, digamos, los antiguos, como te digo, Chevileis, Frankel, que utilizan la formación PAP, en este caso de los
Okay, la formación paja es complicada. Fue una formación muy grande y ahora hay una subdivisión de esta formación. So, para mí creo que es un poco mejor si tenemos una subdivisión un poco más con más precisión para saber cuál rocas tenemos. Y creo que ahora son las formaciones oficiales. Formación Muso, formación Rosablanca, la formación Parea no se utiliza en las publicaciones ahora.
Sí, pero, o sea, yo veía que no hay, digamos, digamos, trazabilidad de las publicaciones internacionales. Sí, o sea, y ¿sabes por qué pasa? Porque es que, digamos, esa parte de la cordillera es extremadamente deformada, ¿sí? y haber hecho esa subdivisión de esas formaciones, digamos que fue un gran error para mí, el concepto y para los geólogos que trabajamos. Sí. Pues nos hemos tenido que acomodar para digamos, solventar requerimientos ante el Estado. Pero a la hora de ser científicos, a la hora de sacar cometemos errores. Creo que allá esas formaciones para como en Rosablanca, digamos, no tienen una continuidad en el terreno, porque un mapa unos 100.000, la geología de las esmeraldas necesita hacer escala unos 10.000, unos 5.000, no 1.000. Y esas colinas que tienen para la formación de un sopa público, la blanca, son muy, por así decirlo, dispersas. Entonces, sí no hay como una continuidad, ¿sí? En el campo de esas formaciones. Entonces, para mí es mejor manejar, digamos, columnas sin necesidad de meterlas en formaciones, porque ¿qué pasa cuando tú vas a explorar una zona donde quieres mirar si hay? Te vas directo a buscar la formación baja que está en el mapa, en la formación uso que está en el mapa. Resulta que como no está, entonces no exploras, ¿sí? Y dejas una zona que de pronto sí puede tener en el Cretácico inferior brechas, venas, vetas, y la olvidas porque simplemente no está cartografía en este mapa actual. Entonces, pues es como la crítica constructiva que vengo a hacer. Y otra cosa, sí, pues me gustaría que visitaras el Oriente para que vieras las grandes diferencias que hay entre Oriente y Occidente. Entonces, es bienvenida, nosotros allá podemos recibirte, podemos llevarte todo para que lo muestras y sigamos investigando las esmeraldas del pueblo.
Muchas gracias por la invitación.
Complementando un poquito si mal no recuerdo, a finales del siglo pasado, yo mismo el servicio hizo unos estudios muy detallados, precisamente tomando en cuenta los materiales. Y por criterios estratigráficos, estructurales, todo se llegó a definir estas formaciones que están ahora manejándose, ¿sí? Entonces, no es decir, para uno, estábamos acostumbrados a ver los superlativos a nuestra formación clásica, pero realmente, uno dice, para el detalle se necesitan más datos, tanto geoquímicos como estratigráficos, también estructurales. Entonces, esos estudios sí ya se realizaron. Y bueno, ha sido como un nuevo aporte. Claro, ya estamos en una cosa de escala muy detallada, obviamente van a en el aire, pero sí.
No entiendo. Busco las informaciones sobre el sitio de Geological Survey of Colombia y para mí fue mi referencia. Y que si el Geological Survey de Colombia dice hay transformación, ahora hay transformación. Pero en la literatura antigua, siempre escribe la formación baja. Y al primo fui muy, no entiendo sobre baja, pero sí, para el antiguo, y ahora, no sé si ahora, ahora la formación baja se utiliza o nunca, ¿sabes tú? Bajas,
Pero eso no pasa nada.
Pero no para con el cinturón.
Ok.
Como distinta, y pues sí, o sea, digamos la información del servicio, sino que todo el mundo se la oficial, así pues digamos, hay estos inconvenientes.
No entiendo que tal vez en las minas sobre la carta dice aquí es formación Rosablanca, pero no estamos 100% seguro si es realmente aquí o acá es la limita. Creo que tal vez hay un poco de diferencia de la mapa en el terreno.
Que es que el mapa se escala unos 100.000, ese mapa que tú utilizas esa escala no sirve. Tú vas al campo y haces la geología de detalle y no te va a funcionar para nada. Entonces, bueno, pero esos son temas, digamos, por así decirlo, ¿cómo se dice? ¿cómo es la- de estandarización, pero digamos, estas son las cosas más importantes que voy a estar lo que te alcanzaba, es que un análisis sistema estaba
Está bien.
escuchando a Manuel el tema del paral y del cronio, ¿por qué tan alto? Entonces siempre ha estado la discusión entre los geólogos de Esmeraldas, yo soy nuevo, pero de los antiguos, entre que si es no, ¿cómo es esto? Hidrotermal no, sino, bueno, o tiene una influencia magmática, sí, tiene una influencia. Entonces, digamos que yo sé que por ejemplo, él defiende el tema de que los cherries fueron acumulados detritos de rocas, por ejemplo, en la cordillera occidental, gas en Vanadio, estas cosas, pero pues hay muchos geólogos acá en Colombia que no comparten esa teoría. Pero pues igual también es lo mismo, o sea, o estoy de acuerdo o no estoy de acuerdo, lo importante es encontrar las esmeraldas al final. Y a la final encontrar las esmeraldas hay una gran pregunta es si las brechas se formaron antes de la esmeralda o después de o las brechas se formaron con la esmeralda. Esa es una gran pregunta que hay. Y en Oriente, que es donde yo trabajo más, allá es claro que la esmeralda se formó antes de las brechas. Es claro cómo los bloques de esmeralda, las rocas que tienen las esmeraldas formadas, son transportados por la brecha y quedan embebidos dentro de la brecha. Entonces, o sea, en relaciones de campo se ve eso. Ahora, las dataciones. Yo no había visto esta datación de Áquila, no la había visto en 2022. Y dice que es de 57 a 60 millones y tiene un rango muy corto. Pero hay una datación que tú muestras en el slide, donde muestras que es como de 70 a 10 millones de años, o sea, un rango muy alto. La Spandelland, en 2015.
Sí.
De 97 a 14, o sea, ¿sí? Que hay igual la duda, está Tassinari diciendo que es de 12. O sea, hay una gran ambivalencia en qué momento se formaron las esmeraldas. Ahora, los trabajos pioneros que fueron de Chevilles, él dice en su publicación que en Oriente se formaron primero las esmeraldas que en Occidente. ¿Sí? Entonces, si se formaron después o antes de la deformación, pues tú lo dijiste, el uplift es del exterior. Entonces, cuando se exploran las esmeraldas, no, que vamos a ir a buscar las brechas, vamos a buscar las fallas, resulta que las brechas y las fallas se formaron después, o sea, tal vez tenemos muchos sedimentos sin deformar con esmeralda. Entonces, son muchas cosas que he podido ver en campo, que no he publicado porque pues, no le he sacado el tiempo, pero sí muy interesante, sobre todo que sigas, porque tienes pues el interés, se te nota que te encantan las esmeraldas, que vengas, que sigas, estudiantes puedan hacer tesis, o sea, genial, genial. Quería venir y gracias.
Bueno, yo creo que ahora
How do you choose the points in the pricing for the average?
I think we will start to do a line, to drill through and to see how the values of thorium and lead will change, to have first an overview. Do we have something constant or do we have big variation between the core and the ring? That will be the first step.
Hay otra. Andrés pregunta, dice que gracias por la charla. Dice que en Peñas Blancas las vetas de cuarzo florita son muy distintivas, que si planea analizar alguna de esas dos.
son en Peñas Blancas, en la parte arriba, dice que hay mucho cuarzo, muy bonito, grande, fluorita también, pero no realmente esmeraldas en la parte arriba. En la parte un poco más abajo hay cuarzo grande, un poco fluorita, creo siempre verde o sin color, pero rosa, creo que es de la parte arriba. Y los dos minerales sé que son cerca de la beta con esmeralda. No siempre en la misma beta, pero cerca.
También dice que la parisita en Peñas Blancas es muy rara. En cuanto a la muestra que planea fechar, ¿la recolectaron in situ?
La gente dice en Rosablanca no realmente hay parecita, pero en Rosablanca hay dos concesiones con esmeraldas, y fuimos en los dos. En una dice que no hay y en la otra tenemos una pequeña esmeralda con una pequeña parecita. Si esta concesión siempre es en la formación Rosablanca, hay parecita, pero si esta concesión es no realmente en el mapa, es sobre la formación Rosablanca, pero si la mapa no es exacta o esta concesión es un poco más arriba y no es de Peñas Blancas, no es de Rosablanca, es it's true. No hay esmeralda, no hay parisita en Rosablanca. So the point is we have the geological formation Rosablanca is quite large, and we had two concessions that were apparently into this formation, and we found one parisite in only one of the concessions. The other one said we don't have. So the big question is the second concession really into the Rosablanca formation? If yes, well, we do have a bit of parasites. If no, then we don't have parasites, and we have different, slightly different processes. One that leads to parasites, and the other one where maybe the fluid is not enriched enough, or something is different and we don't have parasites. But on the top of Rosablanca, I showed sample and they said, no, we don't have it. That is.
Bueno, muchas gracias por asistir. Seguimos esperando este horario. Las próximas charlas que pues, van a ser divulgadas oportunamente. Muchas gracias a todos. Gracias, Carlos.